We are going to look at a differential equations free response question, and this is a AP Calculus style question, but it's not a true AP Calculus exam problem. It came from a third-party book, and I can't remember the source of the problem. But if you want to print the sheet so you can have your own copy to work along with me, you can go to this bit.ly link. And this question does not have separation of variables in it. So if you're looking for separation practice, this is not one to look at. So look at this one. We do have a slope field, and we have a whole bunch of points, which is kind of atypical. AP exam usually doesn't give you this many points. We have a pretty simple differential equation, and we want to sketch the slope field at these 14 points. And so we will simply find these coordinates, and we will plug in the coordinates one at a time to x minus y to see what the slope is. So if I'm at the point, hiccups there, if I'm at -2, 2, then -2 minus 2 is -4. So at that point, I need to sketch a piece of a line that has a slope of -4. That's pretty steep. So I'm going to do that. Then I go to -1, 2. So that's -1 minus 2 is -3. So now I have a slope of -3. And what I do to try to make my slopes as accurate as possible is I visualize, I know I'm going to go through that point, but then I find another point in the grid that if I had a slope of -3, they would connect, and this one down here, that's down 3 over 1. So in my mind, I'm simply connecting those 2 points, but I'm only drawing a piece of a line that goes through those 2 points. That helps me make it a little bit accurate. Doesn't have to be exact. Nobody's going to line up a ruler to check your slopes. So there's that point. And for the sake of time, I'm going to pause this video and finish the remaining 12 points because this is very tedious and I don't want the video to get too long. And here's what I ended up with. So you'd have something like this. And on the AP exam, they will tell you how many points to look for. So some people get carried away and they accidentally sketch one that goes through this point at 2, 0. However, that is not it. So make sure that you only draw slopes through the number of points indicated. Part B, sketch the solution curve that contains the point 0, 1, -1, 1. So for the sake of making this easy to see, I'm going to do this in another color. So -1, 1 is this point right here. Make sure you hit that point. And the easiest way to ensure that is to start at that point and then just follow what the slopes are telling you. And as I go to the right, I start with a slope of -2, but then I see these 0 slopes. I'm going to kind of come in at 0 when I hit that diagonal. These slopes of 1 that all point in the same direction do function as an asymptote for any solutions that don't start on that line. So I'm going to come up and I'm just going to approach that slant asymptote of 1. Carry your solution curves all the way out of the slope field. Once I go to the right, I come back to my point and I work my way to the left, and we're getting steeper as we go up. So something like that would be sufficient for your solution curve. And then part C, find the equation of the straight line solution through the point 1, 0. So now we have a second solution. This time we're going through the point 1, 0. And if I start right here at 1, 0, and if you want to sketch it, that's fine. It's not wrong to draw on this in addition to what we already have. And that is a slope of 1. And if I carry a slope of 1, I will remain on that slope of 1. And the y-intercept is -1. I typically write my linear equations in point slope form. However, in this case, I'm going to write it in slope intercept form. That is a slope of 1. So I'll write 1x just to drive the point home. Y-intercept is -1. And is your work for parts A, B, and C. I do have a part D, though, that didn't fit on this page. So let's go on and look at part D. And you are given a proposed solution, y equals x minus 1 plus c times e to the negative x. And we are asked to show that this is a solution to this differential equation. And we cannot separate and solve the solution ourselves. Even if we could, the fact that they gave you a solution, the easiest way to do this is to take this equation. Since we know y is equal to that, we will substitute that equation in for y. Then I will find the derivative of this equation, so dy dx, or if you want to call that y prime, you can. Dy dx is going to be 1, derivative of x, minus, I'll write 0, and then ce to the negative x. I can just ignore the c. The derivative of e to the negative x is negative e to the negative x, good old chain rule. And dy dx is going to end up cleaning up to 1 minus ce to the negative x. I will take that, and I'm going to substitute this in the place of dy dx. And when I make those two substitutions, what I want to show is that this equation is indeed satisfied. So my left side, dy dx, is 1 minus ce to the negative x. The right side is x minus y, and y is x minus 1 plus ce to the negative x. And then we just do our arithmetic or algebra until we can see that both sides of this equation are indeed equal to each other. And because this question is essentially a proof, they gave me the solution. We're just verifying the solution. Then I don't want to skip steps. I want to show every detail that shows that the two sides are indeed equal to each other. Right here, we can see x minus x subtracts away, and we are left with 1 minus ce to the negative x equals 1 minus ce to the negative x. And that indeed finishes our little proof that that is indeed the solution to the differential equation. Or I should say a solution. There are other solutions, but that is a solution. And we can draw triangle man of victory, and we are done with this question. And that was it for this one. Without the separation, it ended up being quite quick.